All right, so today we're finally tackling Bitcoin. But not just the surface stuff. Everyone's heard about Bitcoin. It's digital money, blah, blah, blah. We're going deeper.
Right.
We really want to understand how it works, the elegant system underneath. And we're using Mastering Bitcoin by Andreas M. Antonopoulos as our guide for this deep dive. So by the end, you should be able to explain Bitcoin like you invented it.
Exactly. Yeah.
I love it. So whether you're thinking about investing in crypto, or maybe you're just curious about the tech, or hey, maybe you just want to impress some people at your next dinner party, this episode is for you.
It's really about, I think, the difference between just knowing that wine exists and then really appreciating, the vineyard, the soil, all the years of labor and love that went into crafting that final bottle of wine you have.
Okay, I love that analogy. So most people, myself included, when they hear Bitcoin, they think digital cash. But you're saying that's not even the right starting point.
Right. I mean, it's like calling the internet email. Yeah, you can send email on the internet, but you're missing the whole point of the internet.
Yeah.
Right. So Bitcoin is, at its core, a decentralized trust network.
Okay. Decentralized trust network. So unpack that for me a little bit.
Yeah, it sounds very buzzwordy.
It does.
Right. But it's actually elegantly simple. Imagine a colony of leafcutter ants, right?
Okay.
Each individual ant isn't very smart. They just follow a very basic set of rules.
Right.
But then together, what they create is incredibly resilient and complex. A whole system, the colony.
So are you saying that Bitcoin is like an ant colony?
In a way, yeah. I mean, every computer that's running this Bitcoin software, we call those nodes. Those are like the ants. They follow the set of rules, they interact with each other, and then boom, this sophisticated system emerges that can actually track and transfer value without needing a central bank or a government.
That's kind of a mind bender, but I think I'm following you so far. But how do transactions actually work in this system, in this ant colony?
Let's say you want to buy a cup of coffee with Bitcoin. So you send a transaction from your digital wallet to the coffee shop's wallet. But here's the thing, it's not just this isolated event, right?
Right.
Each transaction is cryptographically linked to other transactions,
Right.
forming this chain of ownership.
So is it like a trail of breadcrumbs, but for Bitcoin?
Exactly, yeah. And it's completely transparent, so you can actually see how each Bitcoin moved from person to person. And here's where it gets really interesting. Your wallet doesn't just throw all of your Bitcoin at the coffee shop when you pay for a latte.
Okay.
It has to go back through your transaction history and look for the exact amount needed.
Dig through. How does it dig through? This is where I always get a little lost.
So think of your Bitcoin wallet like a physical coin purse.
Okay.
Right? You might have a bunch of different coins in there. Some are worth more than others. And so to pay for something, you've got to pick the right combination of coins, maybe get some change back. Your digital wallet does the same thing. It looks through your past transactions. We call these unspent outputs to make that payment.
So it's like I have to find the right coins in my wallet.
Got it. But where does this blockchain everyone's always talking about fit in? Is that just a record of all these transactions of digging through my wallet moments?
Yeah, so imagine the blockchain as this giant public ledger, kind of like a time capsule. And every 10 minutes or so, a new block of these transactions is permanently added.
A 10-minute time capsule. That's wild. But how do we know that someone can't just mess with the capsule after it's been buried?
And that's where mining comes in, which I think we should probably dig into next.
Okay, mining. So that's always sounded kind of mysterious to me. Are we talking about digital pickaxes here? What's actually going on? Well, there is a sense of digging for gold in that it requires a ton of effort and only a few are rewarded. But instead of pickaxes, we're talking about computing power. So think of it like a global puzzle solving competition. All of these miners around the world, they're racing to solve this incredibly complex math problem. And the first one to crack the code, they get to add the next block of transactions to the blockchain. And they get a reward for their trouble.
So it's like a high-stakes treasure hunt, but what's the treasure?
So the treasure is actually twofold. First, there's the block reward, which is basically brand new Bitcoin that are created and awarded to the successful miner. That's how new Bitcoin come into circulation.
Oh, okay.
The second part is a little more subtle, but just as important. It's the transaction fees. So when you send that Bitcoin for your latte, you can actually include a little bonus for the miners.
Okay. And those bonuses get added to the block reward, making the whole thing even more enticing for the miners to participate.
It's a very clever system. So what kind of math problems are we talking about here? It's not just Sudoku, right?
Way more complex than Sudoku. It involves something called hashing, which, believe it or not, you probably encounter every day without even realizing it.
Really? I love those hidden in plain sight things. Tell me more.
Think about passwords on websites.
Oh, okay.
You know how they're stored as these jumbles of letters and numbers?
Right.
That's a hash. It's basically a way of taking any piece of information, a password, and an entire book, even a picture of your cat, and turning it into this unique digital fingerprint.
So a hash is like a unique ID for any piece of data. Exactly, you got it. Now, in Bitcoin mining, the puzzle involves taking all the data from the pending transactions, plus some other important information, and running it through this special hashing algorithm. And the goal is to find a specific number, it's called a nonce. That, when combined with that block data and hashed, produces a result that fits within a certain criteria. It's kind of like trying to fit a key into a digital lock. But there are trillions upon trillions of possible keys.
Trillions. Okay, that sounds intense.
Yeah, and it's supposed to be. Because this difficulty is what controls how fast new blocks are added to the blockchain.
Right, that 10-minute time capsule schedule.
Exactly, that's not a coincidence. The difficulty of this mining puzzle adjusts automatically based on how much computing power is on the network. So if more miners join the game, the problem gets harder. If some miners drop off, it gets easier.
So it's like a self-balancing system, keeping everything running on time.
Exactly. And this mechanism is actually key to Bitcoin's security.
Okay.
Because even with all that computing power thrown at it, new blocks are still being added at this, like steady, predictable rate, making it basically impossible for anyone to cheat the system.
Well, that's good. That's reassuring. But what happens if two miners solve the puzzle at almost the same time? Isn't that kind of like a fork in the road? Like, what happens then?
That's a great question, and you're right. That can happen. Sometimes the network might temporarily split with different miners adding blocks to different versions of the blockchain. But this is where the brilliance of what we call the longest chain rule comes into play.
Longest chain rule. Okay, break it down for me.
So basically, the blockchain with the most proof of work, which essentially means the one that has had the most computational effort poured into it. That one is considered the true and valid version of the blockchain. It's kind of like a tug of war, where the side with more people pulling ultimately wins.
So even if there's that temporary split, the network will eventually self-correct.
Exactly. It's really a beautifully self-regulating system. And this longest chain rule has huge implications for Bitcoin's security, which I think is worth exploring a little further.
Yeah, that makes sense. This longest chain rule is pretty clever, keeps everything on track. But you said it has implications for Bitcoin's security. What did you mean by that?
Well, to rewrite the blockchain, to go back and change something that's already happened, a bad actor wouldn't just need to solve one puzzle faster. They'd need to outpace the entire network consistently to build a longer chain than everyone else. And remember, the more computing power that's on the network, the harder these puzzles get. It becomes practically impossible.
So the security comes from just the sheer amount of computing power behind it.
Yeah, it's like trying to outrun a steamroller. I mean, I guess theoretically you could do it, but realistically, no chance.
That's a pretty good analogy. So I got to say, hearing you break it all down like this, from ants to coin purses to digital fingerprints, I finally feel like I understand not just what Bitcoin is, but why it works the way it does.
And we've only scratched the surface.
Well, there's more.
Oh, yeah, there's all these different types of wallets, and we could talk about how transactions can be programmed for more complex scenarios. Or the Lightning Network. That's a whole other can of worms.
We'll save it for another deep dive then.
Well, you've definitely given me a lot to think about today. I think what's really sticking with me is this idea of Bitcoin as less about the money itself and more about a trust network.
Yeah.
You're trusting this system even though you're not in control of it.
Right, and that's what makes it so interesting. Because if this technology isn't just about money, what other applications could we use it for? What if we took these same principles, these ideas, and applied them to other parts of our lives?
That's a really good question, and I think I'll leave our listeners with that. If you want to go even deeper on Bitcoin, you got to check out Mastering Bitcoin. It's the definitive guide. It's a wild ride. But my brain is officially full for today. So thanks for joining us for this deep dive into the heart of Bitcoin. And we'll catch you next time when we unpack another fascinating topic.